Very good morning everyone. Today I am going to do a video on allotropes of carbon. Now allotropes are those elements which exist in different forms. That means existence of one element in different forms having different physical properties but similar chemical properties is known as allotropy. Now carbon shows allotropy. Different forms of carbon which shows allotropy, they are called as allotropes. Allotropes basically can be of two types, crystalline forms and amorphous form. Crystalline form of allotropes includes diamond, graphite and Buckminster fullerenes. Whereas amorphous forms includes coal, coke, wood charcoal and animal charcoal. Now, if we discuss diamond and graphite, and graphite both are covalent crystals, but they differ considerably in their properties. दोनों में डायमंड हो या ग्रेफाइट हो, इनफैक्ट बकमिंस्टर फुलरीन भी, they contain covalent bond, but only because one bond is different in each case, they differ in their properties considerably. These differences are due to the difference in their structure. In diamond, each carbon atom is linked to its neighboring carbon atom by 4 single covalent bonds. This leads to a three-dimensional network of bonds. I'll show you the structure. See, this is the structure of diamond and this is the structure of graphite. In case of diamond, each carbon atom is connected to 4 different carbon atoms with the help of a covalent bond, strong covalent bond. Similarly, this carbon will also be attached to 4 different carbons. This will also be attached to 4 different carbons. It's not possible to show a three-dimensional structure on a paper. That is why same structure like this carbon is attached to 1, 2, 3 and 4 carbons. Similarly, this carbon will also be attached to 4 carbons. This will also be attached to 4 carbons with a covalent bond. But in case of graphite, what is happening? See, you can see 2 layers over here. One layer is here and another layer is here. You can just take them as 2 layers like this, 2 layers. So, in this layer you can see hexagonal structures are there. Each layer is consisting of hexagonal structures. Now these hexagonal structures, each carbon is connected to 3 carbons. See, this carbon if you see, this carbon 1, 2, 3. If you see this carbon again 1, 2, 3. So each carbon is attached to 3 carbon atoms. This carbon 1, 2, 3. This carbon 1, 2, 3. But the 4th valency is remaining free. So that 4th valency is attached to the another layer of hexagon. This is another layer of hexagon. So this 4th valency is attached to another force of hexagon, another carbon of hexagon. Now this force, this van der Waals force is so weak that you can just break it like this. This is graphite, this lead is graphite. So this graphite layer is so weak that you can just break one full layer by the simple snip of your finger. Just like this you are breaking one full layer. This full layer you are breaking just by pushing this pencil so simply. So this is the reason why graphite is having is so soft and diamond is the hardest known natural occurring substance. Now let us study both of them in detail. In graphite, the carbon atoms are arranged in flat parallel layers as regular hexagon. Just now I showed you flat parallel layers in form of hexagon. So this is one layer and this is another layer. Each carbon in these layer is bonded to 3 other carbon by covalent bond. Each carbon is bonded by 3 different carbon atoms. So if I take this carbon, so 1, 2, 3. If I take this carbon, so 1, 2, 3. Each carbon is bonded by 3 different carbons with the help of a covalent bond. This black color is all covalent bond, and this dotted line is van der Waals forces. So this is one layer. If I divide it like this, so this becomes one layer, this becomes another layer. So this layer is connected to this layer with the help of weak van der Waals forces. Now graphite has one electron free or unshared, which is responsible of its property to conduct electricity. Now this free electron, which is just bonded by van der Waals forces, it breaks easily. That is why graphite is able to conduct electricity. The layers are held together by weak van der Waals forces. This allows each layer to slide over the other layer easily. Due to this type of structure, graphite is soft, slippery and used as lubricant. Graphite is also a good conductor of electricity due to free mobile electrons in it. Because it is so soft, I just showed you, see, this one full layer is broken. This van der Waals force is broken. So one full layer I can put on the paper like this. That is the reason why it is used as lubricant, why it is used in conduction of electricity. If I talk of diamond, diamond has a network structure consisting of very large number of carbon atoms bonded to each other. A network of structure which is consisting of central carbon atom attached to 4 carbon atom with all covalent bonds. In this case, one was van der Waals force. In this case of diamond, all are strong covalent bonds. Each carbon is bonded to other carbon atom by covalent bonds. Since all the valence electrons of carbon are strongly held in carbon-carbon bonds, that is why diamond is a poor conductor of electricity. That is the reason why diamond is a poor conductor of electricity. Now, if I talk about Buckminster Fullerene, the third allotrope, it contains at least 60 carbon atoms. It looks like a football. The structure looks like a football, and it contains minimum of 60 carbon atoms in it. Fullerenes contain 60 carbon atoms. It can have 10 6-membered chains, that is hexagon, and 12 5-membered chain if it is in pentagon. You can just imagine a football. It has got so many hexagons joined together. Same way, if you join all the hexagons together, total should come to 60 or more than 60, then it's a Buckminster Fullerene. The structure resembles the geodesic domes designed by US architect Buckminster Fuller. So this allotrope or carbon is named after Buckminster Fullerene. It is a dark solid at room temperature. It is very small molecule as compared to diamond and graphite. Only 60 carbon atoms. In diamond and graphite you can have n number, infinite number. But in Fullerene it can have only 60 or just more than 60. It is neither very hard like diamond nor very soft like graphite. So with this I end the video of diamond and graphite. Hope you have understood. Stay blessed, stay safe.